Welcome to the HiRSE-Summer of Testing. This is a collection of tutorials focusing only on testing and is a separate series to the usual HiRSE seminar series.
Hello and welcome to this HiRSE-Seminar Summer of Testing tutorial. My name is Jakob Fritz from the Forschungszentrum Jülich, and my topic today is I have tests. Now what? So let me start with a few assumptions I will make throughout the whole video today. I will assume that you know that and why tests are important. If not, you're very invited to have a look at the previous videos on why to do tests at all and how to do tests in different popular programming languages. Also, I will assume that you already do have tests in your language for your code, so you're ready to get started to get this test up and running. And this talk is meant as an introduction rather than a deep dive into the very advanced features. Towards the end, I will give some glimpse of some advanced features, but there's way more to see than that I will show you today. So I will start with why to automate the tests in the first place. Remember, you already do have tests, you already know how to test your code, but why should you automate this? After that, I will go into some general approach, how this works regardless of this specific system. And after you know this general approach, I will get into how it specifically works with GitHub Actions and with GitLab CI. So, why to do automation in the first place? Well, automation and automating the tests has a few advantages. First, it is identical for everyone, regardless who pushes new code to the server. So it is more reproducible and it is less error prone. So we're all humans and we all make mistakes, and maybe you also forgot to pass one or the other command line argument to a specific command. When you do this for testing, the downside is that your results are not comparable anymore because you tested something different. When you automate these tests, the advantage is that they run this very same every time you push to the server. And every time your colleague pushes to the server, the same tests run also. And last but not least, they cannot be forgotten to run at all. So you don't need to think on, I need to remember to test the new code before pushing it to the server, but the server takes care of it and will test the new code when it arrives and will warn you when whatever broke. So let me start with the general approach of testing. So every time you commit new code to the server, you developed your code on your laptop, you pushed it to the server, be it the GitHub server, GitLab server, and with GitLab, be it the gitlab.com server or a GitLab server at your own premise. And this server detects by presence of files, I'll come to that later, it detects that you want to do continuous integration. And after it detected that, it passes on the jobs to specific runners, GitLab runners or runners for the GitHub Actions. And once these runners finished their job, they will report back the results to the server. And there you can see the results and more afterwards in the web front end of the server. And therefore you can see whether your tests failed or whether they succeeded. These tests are configured using files that you check into your regular Git repository. And these files are YAML files. And I assume that not all of you are familiar with these types of files, so I'll get a little into that. When you have these files, as already said, GitHub and GitLab will detect that these files are present and therefore start a pipeline. For GitHub, they need to be in a separate directory and a specific directory. And then this one is called .github/workflows. And in there, you can have multiple of these YAML files. For GitLab, you place it in the very top directory, so no, not in a subdirectory, but you have to name it .gitlab-ci.yaml. And then GitLab detects this very specific file is present, therefore it will run a pipeline. But how to write YAML files? Well, YAML files are key value pairs. And the keys are strings, and the values can be of different type. They can also just be strings. They can be strings with spaces in it. Then you need to add quotation marks. They can also be integers or floats. YAML will detect that automatically. And they also can be Boolean, so true or false. The structure of YAML is, as said, key value pairs. But the value can also be a list, not only a string or number or Boolean, but also a list. And in this list, the entries can be simple variables, or they can again be key value pairs. And furthermore, you can even nest those. So you can have a key where the value is a list, and the first entry may be a string, maybe a number. Second entry may also be something else. For example, again, a list or a key value pair. So you can nest these into each other. Furthermore, many tests, many jobs of these runners build on top of Docker containers. They run in Docker containers, and therefore I want to give you some information on those too. Docker containers are a kind of visualization. They are created to provide a reproducible environment. So every time you start a specific container, it is in the very same state as the last time. If you change something, you close that container and you reopen it, your previous changes are lost. And you again start in this defined state. So every time you use it and every time you run your tests, you have a clean and predefined state. Therefore, your tests actually are comparable because they don't depend on previous stuff that may or may not happen there. If you have multiple containers, it may be interesting to you that these containers are independent from each other, they are isolated to each other. So they won't influence each other. If one is running, it won't be of relevance to another one running in parallel. Also, images for these containers are available with many different softwares and packages pre-installed. So you don't need to take care to install everything from scratch. And you also have the option to create own images where dependencies that you need for every single job are just already installed. So you install them only once and reuse this image in all jobs, and therefore you are faster, because not in every job you need to do all the installation procedure that may take many minutes. And therefore, because you are faster, you not only save compute time and energy, but you also save time, and because you get your result of the test faster. After giving you the general introduction and the general approach on how to do continuous integration, I want to start with GitHub Actions as the first specific way of doing continuous integration. As already said, you add a YAML file to a specific folder, and this folder is .github/workflows. And GitHub will detect that the YAML file is present there and therefore start a pipeline from this file. You can have multiple YAML files in there, and they can have arbitrary names. And GitHub will start a separate independent pipeline for each of those files. I already gave you the information on why Docker containers are helpful and important. and you need to specify in which Docker container, or based on what Docker image, your jobs will actually run. And for GitHub Actions, you do it with the keyword container, as you can see here. So in this example, we run a pipeline called reuse compliance. It runs on every push and on every pull request, and it just consists of a simple single job, reuse compliance. It is specified on which type of runner it runs. We specify the container. In this case, we use an Alpine as a Linux underlying it, and then we have two steps. One step is that we actually check out the code that we develop because we want to do something with it. And the second step is that we perform the actual compliance check. And for this, we use a predefined Docker action named here. This is done with the keyword uses. So we don't have to type specific commands because someone else already pre-built all that. Another example I want to give you consists of not one, but two jobs. It has to do with linting, so I named the pipeline linting. It again runs on every push and on the pull request and consists of two jobs, Markdown linting and Python linting. And both run as first step the checkout. So they both get the code that you developed because we want to lint this code. And the Markdown linting afterwards runs again a predefined GitHub action, but passes it some variable. And this is done with the keyword with, followed by, in this case, args. So args is the name of the variable, and the content is the path to the file that shall actually be checked, in this case, the README file. The second job that is run in this pipeline is the Python linting. Again, multiple steps, in this case 3. First, the checkout, I already said that. Then we use Micromamba to install dependencies needed for the actual check itself. And there also we pass a variable to it. So using the with argument, we pass in a variable called environment file, and the content is the path to the actual file. And the third step is doing the reformatting, in this case using black. So we pass it a command that shall be put into the shell inside this Docker container. And the command in this case is the Python, where it shall run black on all Python files with some more command line arguments. After showing you how to do continuous integration with GitHub Actions, I also want to show you how to do it with GitLab CI. So also in GitLab CI, you use the YAML file, but in this case, you put it into the top directory of your repository, and you have to name it .gitlab-ci.yaml. And then GitLab will detect that this specific file is present and will start a pipeline from this file. As this file has a specific name, there can only be a single file of this, and therefore only a single pipeline. There are ways around this limitation, and I will come to that later, but most of the time, this one single pipeline is sufficient. This one pipeline can have multiple stages, and these stages are used to organize the execution of your jobs. So all jobs in a single stage are started in parallel, and the next stage is started only after all jobs in the previous stage completed. In this case, you can see that this pipeline has two jobs, one reuse and one test Python job. Both are in the stage called test. And for both, we need to specify which Docker image to use. This time, it is done with the keyword image. In the other example, you see that an image is used and we need to specify a specific entry point. And this image already has everything installed that we actually need, so we don't need to install anything more. And in GitLab CI, your code is automatically checked out, so we don't need to do this step compared to the GitHub Actions. Then we have this part script, and in there are all commands, all stuff that should be done in there. And in this case, it's only a single command, reuse lint. Reuse is already installed because it is included in the package, so it will lint. Reuse lint will check your code, or more specific, the licenses of your code, whether or not they comply with the reuse specification. And the second job that I showed you here is the test Python. In this case, it doesn't lint for the formatting, but it tests for correctness. This job, again, is part of the stage test. We specify an image with an already pre-installed Python, and then we have a before script section and a script section. In the before script, we install the local package and therefore also all dependencies, and then we have a script. In there, there's only a single entry. As this command is rather long, I broke it up into 3 lines. If you do this, please remember to add quotation marks in the beginning and the end, because then YAML will interpret this as a single line. Otherwise, this is just not a valid command. So I do pytest, started in the local directory with a dot, and then pass it to command line arguments. After giving you this introduction, I also want to give you a glimpse of some more advanced features, some more advanced aspects of the GitLab CI. So probably not always. So probably you don't always want to run all tests. And you can add conditions on when individual jobs are actually run. This is done by the keyword rules. In this example, I combined it with the word changes to give GitLab CI that it checks whether these specific files changed in the last commit. If they did, the job is run. If they did not, the job is skipped. There are also other keywords than changes. You can check for existence of files, and for many different things, see the keyword reference for that. In this case, the job only runs if any .py file is changed, then the pytest runs. So when you have a commit that only changed the README, you don't need to test the Python files, and this job will just be skipped. If you change something in any Python file, the job will run and the pytest will test your code again. Another thing is that you can include other files into your single pipeline. So it stays a single pipeline, but it's easier to manage. If you have lots of jobs, it may be helpful to split these long list of jobs into multiple files. And then you can use the include command. And in there, again, are multiple ways. I showed you 2. One is the local keyword, linking, referencing to another local YAML file, and it is included as if it was in your main.gitlab CI YAML file. With this, you can split it up. It can be in a subdirectory. In this case, it is in the directory of continuous integration. Furthermore, it can not only be local files, but also remote files. This is done with the keyword not local, but remote, and you give it a URL pointing to a YAML file. Again, there are more ways. See the keywords reference for the other options for inclusion of more jobs. Previously, I said that you have a single pipeline, and normally this is sufficient. If this is not sufficient and you need more, you can have so-called child pipelines. So your one main pipeline triggers more pipelines that run again. This is done with the keyword trigger. After trigger, there is include and a link to a YAML file. And this YAML file is a separate new pipeline with multiple stages, with multiple jobs. There are more keywords than the include, so you can specify on whether your main pipeline will wait until the child pipeline is done, or whether it will just start the child pipeline, but it won't wait for it to be finished, so the two pipelines can run in parallel, and many more tweaks that you can set to this child pipeline. If you have code that shall run in multiple configurations, you may not want to repeat yourself writing very similar tests where you just change the value of one single variable, because this is boring, and again, this is error prone. And for this, GitLab CI offers you the parallel matrix keywords. You can see it here. In the parallel matrix, I have a list consisting of 2 entries. Each entry has the parameter A and parameter B. The values of those are again lists, here in blue. And GitLab then creates a matrix from these. And for the upper part, the matrix will have 6 entries because you have 3 values for the first one, 2 for the second, so there are 6 combinations. And it will append the combinations from the second part of the list, in this case also 6, and will therefore start a total of 12 jobs, all performing what you wrote in scripts. In this case, it will start PyTest. The values of these parameter A and parameter B are handed over to the commands in script as environmental variables. So if your code uses those, you can vary it rather easily and run similar tests with different variables. Maybe you have jobs that build on each other. So if you have a compiled language, you may want to have a job that compiles your code into an executable, and then you want a job that tests your code. If you do it like that, you need to pass the executable from the first to the second job. You can do this with so-called artifacts. This is done with a keyword artifact, and then you pass a path to GitLab CI. In this case, it is a directory, but it can also be a link to a specific file or to a file name including wildcards. With this, these files are shared with all jobs in later stages. Not at the same stage, but in later stages. And also, the files in the artifacts are available for you to get via the web front end after the job finished. In this example here, it's not a compiled executable, but the job created a website that is rendered into a folder called public, and this folder is then put as artifact, and therefore this website is available after the job finished, fully rendered in this single directory. Furthermore, if you have jobs that build on each other and you have more jobs that are independent from those, there is no point in having these other jobs wait for all previous jobs to finish if they don't depend on them. And you can circumvent this with a so-called directed acyclic graph. With this, you specify which jobs need to be finished before a specific job can run. You do this with the keyword needs. In the upper example, you see these empty brackets. So it doesn't depend on any other job. And it will start and picked up by a runner as soon as the pipeline is started and as soon as the runner has capacity to actually execute it. The lower job depends on the upper job. So it will wait until the upper job is finished. And this happens although they are part of the same stage. And if you recall what I told you previously, jobs in the same stage are executed in parallel or in arbitrary order. In this case, there is no arbitrary order because one definitely depends on the other, and therefore it will be executed after the other. And you can build larger trees from this. and therefore the jobs run as soon as possible, as soon as all required previous jobs are actually finished. And with this, I want to come to some more further reading to where to look for more specifics. So I warmly recommend you the GitHub Actions documentation online and the GitLab CI documentation online. And furthermore, I already pointed to it once or twice throughout this video, there is a keyword reference, so the GitLab CI YAML documentation file. And in there you see all possible keywords with all possible options. So if you're looking for something specific, you may have a look there, because probably it is possible in GitLab CI, and you just need to put it into the correct way into your YAML file so that GitLab knows what to do. And with this, I want to sum up today's video. I showed you that automating tests is important to reduce errors. Please don't always perform them by hand, but just automate it. It's an effort you make once, but you can get rid of doing this repetitive task each and every time you change your code. Furthermore, I gave you general information on involved technologies such as YAML or Docker. I showed you the overall approach that is rather similar for GitHub Actions and for GitLab CI, and gave you examples for specifically GitHub Actions and specifically GitLab CI, and closed with a glimpse of some more advanced features of GitLab CI. And with this, I want to close the video. I want to thank you for your attention and wish you a good day. Goodbye.
Thank you for watching this tutorial. Please check out the slides on Zenodo linked below and see you next time.